Hello, Math 95 students. So our class will basically consist of three big topics. They are quadratics. Quadratics is the first big topic. A quadratic function is any function that has an x squared term in it. It might have several other things, but the x squared is the highest exponent term in the polynomial, and that's what makes it a quadratic. We're going to learn several things. That will be the biggest topic. We're going to learn how to factor. We're going to learn the quadratic formula. We're going to learn how to graph. So those are three big things we're going to learn how to do with quadratics. The next big topic is rationals or rational function. So a rational function is anything that can be written as a fraction. Anything that can be written as a fraction can fit in our brains. That's why it's called rational, because it is a rational thought. It can fit in our minds. So anything that can be written as a fraction, such as like 2x plus 1 over x squared minus 4x plus 3, that's an example of a rational expression. We're going to learn how to simplify those, how to add, subtract, multiply, divide those things, and how to solve them. And the third big topic is radicals or radical functions. A radical is that kind of a symbol right there, and it may have a number right here. It may not have a number, or it may have a number. It may have like a 5 right here or something. But then it has some sort of expression in here. Let's say 32x to the 7th, y to the 5th. And we learn how to simplify that, how to add, subtract, multiply, divide, those things. So those are the three big topics. This is going to occupy a lot of pretty much the first half of the course, the quadratics. So this is chapter 8 and chapter 9, chapters 8 and 9 of our textbook. Rationals involve chapter 12 and radicals involve chapter 13. Okay, so moving on, we're going to go right into section 8.1. Section 8.1 is how to factor polynomials. It's mainly factoring. There's a few different kinds of factoring. The most basic kind of factoring is called GCF, greatest common factor. That's the most basic kind of factoring there is. You should always try to do this first before we do any other kind of factoring that we're going to learn. I'll show you how to do that. Let's say you had something like, let's say 6x squared minus 4x to the 5th. And we're trying to factor out the GCF, the greatest common factor of these two terms. Well, what is the biggest number that can evenly divide out of a 6 and a 4? That would be 2. 2 goes evenly into 6 and into 4. So I'm going to factor out a 2. And then what can I divide evenly? What's the biggest thing that I can divide evenly out of an x squared and an x to the 5th? Well, that would be an x squared. So what is left when I divide both of these terms by 2x squared? 6 divided by 2 is 3, and x squared divided by x squared means there's no x's left. So it's just, or it would just be x squared divided by x squared is 1, so it would just be 3 times 1, which is just 3. So all I have here in the first term is a 3. And then what's left when I divide 4x to the 5th by 2x squared? 4 divided by 2 is 2, and x to the 5th divided by x squared. You remember what to do when you divide variables is you subtract their exponents. So it's going to be x to the 5 minus 2. So it's x to the third. Okay, so this would be the proper way to factor 6x squared minus 4x to the fifth by the greatest common factor. I want to show you that this is the exact opposite of distributive property. If we were to distribute the 2x squared into here, 2x squared times 3 is 6x squared. 2x squared times negative 2x cubed is negative 4x to the fifth. So factoring is kind of the anti-distributive property. Because I'm anti-distributing. Instead of distributing the 2x squared into the 3 minus 2x cubed, I'm taking this and I'm pulling something out. I'm dividing something out of both of these terms. All right, let's do another example of that. Let's say we had, let me find a good example here in the book. Let's say we had 3x plus 21. What can we divide out of a 3x and a 21? Well, that would be a 3. I can factor a 3 out of both terms. What do I have left when I divide both of these terms by 3? Well, on this term, I'm left with an x. Because 3 divided by 3 is 1, so it's just a 1x, or just x. What's 21 divided by 3? 7. So I'm left with 3 times x plus 7. Again, if I were to distribute this, what would I get? I would end up back where I started, 3x plus 21. So that's how we know we've done it right. We have now factored this properly. Let's keep going. More examples. 8x squared minus 6x. What can I factor out of here? The biggest thing that can go into here would be a 2x. So what's left from these two terms when I factor out a 2x? Divide that. I'm left with 4. And then x squared divided by x. Subtract the exponents. I'm left with an x to the first. Do it here. 6 divided by 2 is 3. X divided by x means it's just 1. So 3 times 1 is still just 3. So this is the proper way to factor that. One more example of that. 6x cubed plus 12x squared. What can we factor out of this? What's the biggest thing? Well, we could factor out a 2 or a 3, but the biggest thing we could factor out of a 6 and a 12 is actually a 6. 6 is the biggest number that will factor out of both of these. And then what about the x cubed and the x squared? Well, I can always take the smaller variable out of both. So I can factor out an x squared from both of those. So that's the GCF, the greatest common factor. What's left? 6x cubed divided by 6x squared leaves me with, well, 6 divided by 6 is 1. X cubed divided by x squared just leaves me with an x to the first. So it's 1x to the first, or simply x. You could also think, well, what if I multiplied 6x squared times x? Well, then I'd get 6x cubed. And then 12x squared divided by 6x squared would leave me with 12 divided by 6 is 2. And then x squared divided by x squared leaves you with 1, so it's just simply a 2. Alright, so this is the answer to that one. Alright, let's do a few more of these. The more examples, the better. Let's do 20x squared plus 35x. Let's do that one. Let's do 14p cubed minus 21p squared. Let's do a harder one. Let's do 12x to the fourth y squared minus 6x squared y cubed plus 15xy squared. Okay, go ahead and hit pause and try to do these on your own. Okay, so here's what we do. What's the biggest thing that can factor out of here? 20 and 35, that would be a 5. and then x squared and an x, I'm factoring out an x. I'm factoring out 5x. I'm dividing both of these terms by 5x. It leaves me with 4x plus 7. The biggest thing I can take out of a 14 and a 21 is a 7, and p cubed and p squared would be p squared. That leaves me with 2p minus 3. All right, now I'm looking at 3 terms here. What's the biggest number I can divide out of a 12, a 6, and a 15? That would be 3. What about an x to the 4th, an x squared, and an x? That would be x. What about y squared, y cubed, and y squared? That would be y squared. Now, each one of these divided by 3xy squared. 12x to the 4th y squared divided by 3x y squared leaves me with 4x cubed. There's no more y there. All right, divide this one by that. I get 2xy. And then here I get plus 5. And then there's no more x or y. Okay, on to another kind of factoring, which we will call trinomial factoring. Trinomial factor is when you have 3 terms that is in this kind of a format. It's got an x squared term, an x term, and then a constant term. So for example, let's say we have x squared plus 6x plus 8. All right, this is actually another, it's kind of an anti-distributive property. So just to show you, remember when we used to have to FOIL, do the FOIL method, or I would call it the double distributive property. Let's say we had x plus 4 and x minus 8, and we had to distribute that. So that would give us x squared minus 8x plus 4x minus 32, and then we combine the like terms in the middle. We get x squared minus 4x minus 32. Well, this is the opposite of that. This is going the opposite direction, where you start with this and you have to get to here. So the way that we do that is we do 2 sets of parentheses, and we say, we know we got to look like this, so we got to say, what did we do? What did we do to get here? We say, well, to get this term, we multiplied these 2 terms. So we say, what 2 things multiply together to get x squared? X and x. So we're going to put x and x here. And then here we say, well, how did I get the 32? Well, I multiplied 2 numbers to get negative 32. But those numbers also combined with the x's in the middle here to end up adding to get negative 4. So you say, what? You have to solve a puzzle here with 2's. These 2 numbers have to multiply to get the last number and add to get the middle number. Let me say that again. They multiply to get the last number, and they add to get the middle number. That's the puzzle you have to solve, the mystery. What 2 things can multiply to get negative 32 while at the same time adding to get negative 4? Well, if you have trouble, you need to write down 32 and write down the things that multiply to get 32, like, okay, 1 and 32, 2 and 16, 4 and 8. And that's all. So then you say, well, which ones of these could add to get negative 4? Well, since it's a negative 32, one of these has got to be negative, and one of them's got to be positive in order to add, in order to multiply to get the negative 32. So to add to get negative 4, if I make the 8 negative and the 4 positive, plus 4 minus 8, then that will multiply to get negative 32 and add to get negative 4. So let's take that skill back to this one. This one's a little more simple. We start by writing 2 sets of parentheses, and we know it's going to be an x and an x because that has to multiply to get x squared. Then we say, what 2 numbers multiply to get 8 and also add to get 6. Well, what are the factors of 8? 1 and 8, 2 and 4, and that's it. Which one of these are going to add to, not only multiply to get 8, but also add to get 6? The 2 and the 4. And since it's a positive 8, they're either both going to be positive or both going to be negative. And so since they have to add to get a positive 6, they're both going to be positive. Plus 2 and plus 4. This is the answer. This is how we factor x squared plus 6x plus 8. Just want to show you something. If I were to multiply this out, I would get x squared plus 4x plus 2x plus 8. And then combine my like terms in the middle, what do I get? X squared plus 6x plus 8, which is back where I started. That's one way you can check yourself to see if you factored correctly. Is if you distribute it, do I end up backwarded? Okay, let's do another example. Let's factor x squared plus 8x plus 12. Alright, you may want to pause it and see if you can do it before I work it out. Alright, so what multiplies to get 12 and adds to get 8? Out of these choices, 2 and 6. Are they both going to be positive? Or are they both going to be negative? Is one of them going to be positive or negative? Well, if they're going to multiply to get a positive 12, they both have to have the same sign. So it's either both positive or both negative. And since they add to get positive 8, they are both going to be positive. Let's try this one. Again, pause it and see if you can do it. Alright, let's do 36. That'd be 1 and 36, 2 and 18, 3 and what? 3 and 12, 4 and 9, 6 and 6. So which one of these could possibly add to get negative 12? Well, 6 and 6. They have to multiply to get positive 36 and add to get negative 12. That's kind of strange. How are they going to multiply to get positive 36 and add to get negative 12? To multiply to get positive 36, they got to have the same signs, a positive times a positive or a negative times a negative, to give you a positive 36. And if they're going to add to get negative 12, then they both need to be negative. So now we know x minus 6 and x minus 6. Alright, another. What number am I on here? Number 4. Again, I know it's going to be a W and a W, but what multiplies to get negative 20 and adds to get negative 1? 1 and 20, 2 and 10, 4 and 5. That's it, isn't it? So which one of these could possibly give me a negative 1 if I add it together? Well, they got to multiply to get negative 20, which means one of them's got to be positive and one of them's got to be negative. So if I choose the 4 and the 5, if I make one of them negative, which one should I make negative to add to get negative 1? Well, if they're going to add to get negative 1, the bigger number has to be negative. If that was a plus 1, the bigger number would have had to have been positive. So it's a 4 and a negative 5. Plus 4 minus 5. Alright, another example. X squared plus 5xy plus 6y squared. Alright, this one may throw you for a loop because it's got an x and a y in it, but hopefully we can make this seem simple. Do it the same way you've been doing it. We know it's going to be an x and an x, And to get that y squared, we know it's going to be a y and a y. Now, so this is to make it simple. So now all you got to do is figure out what number goes in front of the y to multiply to get 6 and add to get 5. What two numbers can multiply to get 6 and also add to get 5? A 2 and a 3. So this is the proper way to factor that. Alright, what if we had this? 3x minus 15 plus x squared. Okay, this one looks different than the previous ones. But it's not different, it's just arranged differently. You need to rearrange it to make it look like the rest of the problems we've just done. We need to put it in the standard order, which means the highest exponent variable comes first. So I'm going to put the x squared first. Then the next variable comes next, the next highest exponent, which would be plus 3x. And then the constant that doesn't have a variable comes last. Now it looks like all the previous ones we've done. And you do it the same way. What, it's going to be x and x. What multiplies to get negative 15 and adds to get 3? You only have two choices. 1 and 15, 3 and 5. And it's got to be a negative. So one of them has to be positive, one of them has to be negative. You know what? I don't think this one is factorable. I don't see any way. Certainly 1 and 15 can't add to get 3. And 3 and 5 certainly won't add to get 3 either. If I make one of them positive, one of them negative, it's just going to add to get 2. So there's no way. There's no way it's going to happen. When it will not factor, you say that this expression is a prime expression. Prime means it has no way to factor. It is only factorable by 1 and itself. It's just like 7 is a prime number because the only factors of 7 are 1 and 7. This polynomial is prime because nothing else besides 1 in itself will multiply to get that. So when it won't factor, you call that a prime polynomial. All right, another example. Let's say we have x squared minus 10x plus 16. See if you can do that one. Alright, what multiplies to get 16 and adds to get negative 10? It's going to have to be that 2 and that 8. And if they're going to multiply to get positive 16, they got to both be positive or both be negative. And since they got to add to get negative 10, they're going to both be negative to add to get negative 10. Hopefully you're getting a little bit more of a feel for this. Alright. There are two more kinds of factoring that I want to cover in this video. This is actually covering sections 8.1 and 8.2. And 8.3, I guess I will wait on that one. So I will only do one more kind of factoring in this video. And then I'll wait to do the other kind of factoring in another video. So this third kind of factoring is called a difference of squares. Difference of squares. For example, x squared minus 4. The reason this is called difference of squares is because, number one, it's a difference. That means a minus. It has to be minus. If it's plus, this does not apply. It has to be a minus sign. A difference of what? Squares. That means perfect squares. That means two terms that are perfect squares. A term is a perfect square if something times itself gives you that term. So x squared is a perfect square, and 4 is a perfect square. What multiplies to give x squared? X and x. So I'm going to put an x and an x there. What multiplies to give you 4? 2 and 2. So I'm going to put a 2 and 2 there. And the pattern will always be 1 plus and 1 negative. A positive and a negative. That's always going to be the pattern. So the general pattern, a squared minus b squared, always factors as a plus b. A minus b. It's called difference of squares. Let's do another one. Let's say you had x squared minus 100. What's the square root of x squared? X and x. What's the square root of 100? 10 and 10. So plus 10 and minus 10. Pretty simple. Let's say you had 9x squared minus 16. Again, what multiplies to get with itself to get 9x squared? 3x times 3x. What multiplies with itself to give you 16? 4 and 4. So plus 4 minus 4. Let me see if there's any other examples that I need to show you with this that might help you. Okay, let me show you two more examples. Two more examples that will actually put some of this together. Let's say you had the instructions say to factor completely. And you have this question, 4x squared minus 36. Okay, what kind of factoring have we learned so far? GCF, trinomial, and difference of squares. All right. Advice to you. Always look for a GCF first. Do this first on every problem. You won't always be able to find one, and you may have to do something else, but do this first. It'll make the rest of the problem easier. Is there a GCF that I can factor out of this? Yes, there is. What? What can divide evenly out of a 4 and a 36? 4 can. What's left when I divide both of these by 4? X squared minus 9. But factor completely means that I look at what I just did and I say, can I do even more? Can I factor what's left? Again, can I factor it more than I already have? Will this part, can I do something else to that? And I can. Because look at it. What is this? This is what we just saw. It is a difference of squares. So this 4 comes down. It comes along for the ride. But this part will break down even further. To what? The square root of x squared is x and x. The square root of 9 is 3 and 3. So plus 3 minus 3. This is factored completely. Let's try another. All right, go ahead and try that one. Okay. Is there a GCF? There sure is. What is it? 2. So what's left when I factor out the 2? X squared plus 7x plus 12. Then I look at this and I say, can I do some more to that? Can I factor that as a trinomial? You bring the 2 down And you can factor this part some more, x and x. What multiplies to get 12 and adds to get 7? 4 and 3, 3 and 4. One thing I should have said earlier, it doesn't matter if you put the x plus 4 and then the x plus 3. Because when you multiply two things, it doesn't matter what order they are. Like 3 times 2 and 2 times 3 is the same thing. So it doesn't matter if you put x plus 4 and then x plus 3. So it'll still be correct either way. Alright, let's do some more of those. 12x cubed minus 75 x 36x plus 4x cubed minus 24x squared. Go ahead and try them. What can I do to this? I can factor out a GCF. What GCF can I factor out? I can factor out a 3x. What's left when I factor out 3x? 4x squared minus what here? 25. Right? 3/4 makes 75 cents. And then this is a difference of squares. So bring the 3x down. What's the square root of 4x squared? 2x. 2x. What's the square root of 25? 5. And 5, so plus 5 minus 5. Okay, now look at this one. We want to rearrange this first. I'm going to put it in standard order, which is the highest exponent first. 4x cubed comes first. The next highest exponent is minus 24x squared. Then the plus 36x. Look for GCF. The GCF here is 4x. What is left when I factor out a 4x? I have x squared minus 6x plus 9. Now will this factor more? The 4x comes down. The x squared, I put an x and an x. What multiplies to get 9 and adds to get negative 6? That would be a negative 3 and a negative 3. And I'm done with that. Alright, one more thing to show you here. Alright, is there a GCF here? Yep, 5. And also an x. I'm taking out 5x. But here's the trick to this last problem. When your first term is negative, you're going to factor out the GCF as a negative. I'm going to factor out negative 5x instead of just 5x. When I do that, when? Only when my first term is negative. Okay. So I'm dividing all these things by negative 5x. What's that leave me with? That leaves me, when I say negative 5x cubed divided by negative 5x, that leaves me with a positive x squared. And just to let you know, each one of these is going to, when it's divided by a negative, is going to change its sign. Like 30x squared divided by negative 5x is going to be minus 6x. And negative 40x divided by negative 5x is positive 8. Will this factor some more? Yep. Bring the negative 5x down. X and x. What multiplies to get 8 and adds to get negative 6? That would be a negative 4 and a negative 2. And it's done. Alright, that's the last example we're going to do. What that does, again, is it covers sections 8.1 and 8.2. So go ahead and try to do your homework for both of those sections in Math Excel. That will be due, both of those sections will be due next, this upcoming Tuesday night. The GMC administration said that we needed to have at least one assignment due each day that we would have had class. So since we're Thursdays, I'm going to have at least one assignment due each Tuesday and Thursday night. Your attendance will be based on that. If you don't do the assignment, you get counted absent for that day, as well as getting a 0 in the grade book for that assignment. If you do the assignment, no matter what your grade is, you get counted present for that day. Anything else I need to say about this? I hope that I know that I'm going very fast through these videos. I'm trying not to make the video last too long, but I hope you will feel free to pause this. That's the great thing again about this, is you can pause it whenever you need to slow this learning process down as much as you want. Feel free to text me through the Remind app, through the Remind texting, if you have any questions. Good luck. Hope you do well on it.